Imagine standing in the high Arctic. The wind is just, howling across the ice, whipping the snow so hard you can barely see 10 feet in front of your
All
face.
right, the kind of cold that just cuts right through.
Exactly. I mean, the ambient temperature is -40, but the wind chill is sitting at a bone-snapping -60 degrees Celsius.
Which is, frankly, hard to even comprehend if you haven't been in it.
Yeah, it really is. And in this scenario, you have a target, like a hostile asset, sitting 300 kilometers away.
Okay.
Now, historically, dealing with that specific threat is a problem that would take massive coordination, right? Like heavy bomber flights from bases thousands of kilometers south, and honestly, a whole lot of luck to solve.
Oh, absolutely. A logistical nightmare.
But today, standing in that blizzard, you pull out what looks like just an off-the-shelf Android tablet.
Literally just a tablet.
Yeah. You tap a screen, and within 2 minutes, using this decentralized digital network, you have just called down a supersonic precision strike from the edge of the atmosphere.
It's wild to think about.
And to ensure that specific capability exists, Canada just wrote a check for $2.6 billion.
I mean, it sounds like a scenario pulled straight from a science fiction novel, right?
Right.
But as of right now, that is the exact operational reality the Canadian Armed Forces are building.
Yeah.
We're looking at a complete paradigm shift here. They're moving away from legacy hardware and entering an era where software, digital networks, and high-mobility strike platforms really define the battlefield.
Welcome to today's deep dive. It is June 8th, 2026, and our mission today is to unpack this monumental shift in Canadian military doctrine.
And we have a lot to cover.
Oh, we really do. We've got a massive stack of sources to go through with you today. And when I say you, I mean you, the listener who is just as insanely curious about how the world actually works as we are.
The ones who want the actual nuts and bolts, not just the headlines.
Exactly. You don't just want the news alert, you want the underlying mechanics of how things happen. So we are looking at official U.S. Defense Security Cooperation Agency releases, deep in the weeds defense industry magazines, a draft of the military's brand new doctrine called RCA M.1, and even some brutally honest, unfiltered debates happening right now on Reddit.
Which is always a fun place to get the unfiltered take.
Always.
So we are synthesizing all of these disparate threads because that $2.6 billion check for 26 high-mobility artillery rocket systems, the HIMARS,
Right.
that's not just a standard procurement order. It's a fundamental rewiring of how the military fights.
Yeah, it changes everything.
It really does. But to comprehend the sheer destructive power of these massive rocket launchers, we first have to understand the invisible digital thread that makes them lethal.
Because the hardware is useless without the software.
Precisely. We have to examine the analog problem in a digital battlefield.
So when I think of calling in an airstrike or like artillery support, my mind immediately goes to the movies, right?
Oh, for sure. The classic Hollywood scene.
Yeah, you picture a soldier pinned down behind a rock, screaming into a heavy, static-filled radio like, I need air support at these coordinates right now, over the deafening sound of gunfire.
Right, trying to talk over the explosions.
Exactly. It seems so chaotic and so heavily reliant on just raw voice communication.
Well, the crazy thing is, for a long time, that movie trope was the actual operational reality.
Really?
Yeah. Historically, the individual responsible for this is the Joint Terminal Attack Controller, or JTAC.
Okay.
These are highly specialized personnel embedded right there with the ground troops. Their entire job is to coordinate air and artillery support.
Mm-hmm.
And for decades, they had to do this entirely over voice networks.
Just talking on the radio.
Just talking. They would literally have to talk the aircraft onto the target using this very standardized format called a nine-liner.
I've seen that term in the sources. What actually goes into a nine-liner? Because,
Yeah.
I mean, if it takes as long as the documents indicate, it must be way more complex than just reading off a GPS coordinate.
Oh, it's incredibly dense. A nine-liner is this standardized brief, right?
Yeah.
So the JTAC has to first establish communication, authenticate their identity so the pilot knows they're friendly, and then sequentially transmit 9 distinct pieces of information.
And they can't skip any of them.
Nope. They have to give the initial point where the aircraft should start its run, the heading, the distance, the exact target elevation.
Whoa, okay.
The target description, the target location, how the target is being marked, like with a laser or smoke,
Okay.
the location of friendly forces, which is obviously critical, and finally, the egress route, so the pilot can actually escape safely.
That is a massive amount of information to convey.
And all of this is done by voice,
Yeah.
often while actively under fire, and the pilot has to read it all back to ensure there are no catastrophic misunderstandings.
So it's reading, confirming, double-checking, correcting static interference.
Exactly.
And the sources note this whole process could take 15 to 20 minutes to complete.
Yeah, up to 20 minutes just to get the okay to drop a bomb.
And in modern warfare, I mean, a 20-minute delay isn't just an inconvenience. The target moves.
Right.
Or the aircraft gets tracked by radar and shot down.
Oh.
Or the JTAC's position gets triangulated by enemy electronic warfare units and they get compromised.
Exactly. That time delay is a lethal vulnerability. Major Richard Parent, who is the project director for the Canadian Army's digitization efforts, he pointed out in our sources that doing things the analog way on a modern battlefield basically guarantees failure.
Yeah, you just can't compete.
You simply cannot support land forces by voice safely or quickly enough anymore, especially in a fast-paced, multinational coalition environment where literally seconds dictate survivability.
Because the cognitive load on the JTAC to manually calculate and communicate all those variables has to be immense.
Immense. And that's not even mentioning the physical load.
Okay, let's talk about that physical load, because this blew my mind when I was reading the sources. The sheer weight these soldiers carry is staggering. Almost 30% of an observer's gear weight is just batteries.
It's just batteries. It's wild.
How does it even happen?
Well, think about the equipment required to orchestrate a conventional strike. They carry handheld thermal imagers, heavy laser target designators with thick umbilical cords, ruggedized military laptops, and these bulky multi-band radios.
Right, and all of that needs juice.
Exactly. All of those draw massive amounts of power. A dismounted soldier is forced to carry pounds and pounds of heavy lithium-ion battery blocks just to keep the equipment alive for a multi-day patrol.
And in the Arctic cold, those batteries drain even faster, right?
Oh, significantly faster.
Yeah.
So the future of warfare is fundamentally about shrinking those power requirements. It's about taking a bulky anti-jamming antenna that requires its own heavy power supply and reducing it to like a puck-sized device.
Which brings us to the solution. The military calls it the DACS system, which stands for Digitally Aided Close Air Support.
Right.
And the hardware interface for this advanced multi-million-dollar killing chain is literally an off-the-shelf Google Pixel tablet.
It is. It's running an open-source architecture called the Android Tactical Assault Kit, or ATAC.
Yep.
Yeah. It's essentially a highly specialized software application with a geospatial mapping engine. So instead of a JTAC pulling out a physical paper map, manually calculating grids, and reading a 9-liner over a voice radio.
Which takes 20 minutes.
Right. Instead of that, ATAC provides a shared digital map. The JTAC sees their own position, they see the position of friendly forces, and they see the target.
Almost like a video game interface.
Very much like that. They drop a digital pen on the target, input the parameters into a standardized menu, and the software translates all of that into a burst of digital data.
I just love the idea that the interface for coordinating the destruction of an enemy asset is fundamentally the same device you use to, scroll through recipes in your kitchen.
It's the exact same glass screen, yeah.
And the real-world validation of this is incredible. Let's look at that anecdote from Bold Quest 19 in Finland.
Oh, it was a huge moment.
It was a massive multinational interoperability demonstration.
Yeah, sponsored by the U.S. Joint Staff. So you had 70 JTACs representing 16 different nations out on the tarmac.
Just a massive gathering of air controllers.
Exactly. And parked out in front of them was this crazy array of international air power. You had a French Rafale fighter, Finnish FA-18 Hornets, a U.S. Cessna, a German Learjet.
All these different systems.
Right. The objective was a validation process to see which nations could successfully, digitally, talk to these disparate aircraft systems using their respective gear.
And the Canadians just absolutely crushed it.
They really did.
They had what the Collins aerospace representative actually called a rock star moment.
Which you don't hear a lot in defense procurement testing.
No, you don't. So while the other 16 nations were sweating, struggling for up to 20 minutes to get their complex, custom-built systems to communicate, or literally watching their software crash and reboot in real time.
Which is just a nightmare scenario.
Yeah, total nightmare. But the Canadian Army JTACs, they just pulled out their Android tablets, they tapped the screen, generated the digital strike package, and connected with all those different international aircraft in under 2 minutes.
Green lights across the board on the test tool.
Under 2 minutes.
That speed is the difference between neutralizing a high-value target and arriving to find an empty field.
Right, because the target isn't going to sit around for 20 minutes waiting for you to reboot your laptop.
Exactly. But the real triumph there wasn't just the speed, it was the interoperability. The Canadian system seamlessly translated its data to French, Finnish, American, and German aircraft computers without a human needing to act as a voice interpreter.
Okay, wait, hold on. I have to push back on the hardware choice here.
Sure.
Because we are talking about the highest stakes imaginable, right? Coordinating precision munitions from international fighter jets
Yeah.
is relying on an off-the-shelf commercial tablet actually secure enough for warfare.
That's a valid question.
I mean, I have a tablet. Sometimes it freezes when I have too many browser tabs open. Sometimes it just randomly drops the Wi-Fi.
Yeah.
If it's literally a Google Pixel, what happens when the screen locks up or the Bluetooth disconnects while a supersonic missile is waiting for coordinates?
It's a completely natural concern for sure. But it helps to think of the tablet as nothing more than a smart TV remote.
A remote.
Yeah. The remote itself isn't doing the heavy processing, right? And it doesn't hold the secure data. The tablet is merely the glass screen. It's just the human-to-machine interface.
Okay.
The actual brain and the impenetrable, secure connection are handled by heavily encrypted tactical hubs that the tablet plugs into.
So the supercomputer is hiding in the backpack.
Exactly. The soldier carries a hub that integrates all the heavy hitters. You've got a tactical net rover, a military-grade laser rangefinder, anti-spoofing GPS modules, and heavily encrypted radios like the Harris 152A.
And that radio is what actually sends the signal.
Right. That radio connects to the Link 16 tactical data network.
Yeah.
Now, Link 16 is a military tactical data link network used by NATO. It isn't like your home Wi-Fi.
I would hope not.
No, it uses a time division, multiple access architecture, and it is frequency hopping at over 76,000 times a second across hundreds of frequencies.
76,000 times a second.
Yeah, it's practically impossible to track. That's how it avoids enemy jamming and interception.
So basically, if the Google tablet freezes, the soldier can literally smash it, pull a backup commercial tablet out of their pocket, plug it into the radio hub, and the encrypted mesh network hasn't dropped a single packet of data.
Precisely. The security resides in the architecture, not the glass screen.
That makes so much more sense.
And this tablet hub configuration is really just the foundational layer for something much more expansive. The Canadian Armed Forces call it the Joint Fires Modernization Project, or JFM.
GFM, right?
Right now, a JTAC uses the tablet to talk to a specific airplane. But the ultimate goal of JFM is to remove the specific airplane from the equation entirely.
Wait, how does that work?
Well, eventually, the soldier will use that tablet to access a unified, coalition-wide toolbox of weapons.
Ah, okay. The sources actually include a brilliant analogy from Major Parent on this.
Oh, the hammer analogy.
Yes. He says, if a ball-peen hammer is what is needed, you don't need to call in a sledgehammer just because it's the closest.
It's a perfect way to describe it. In a fully integrated JFM environment, the JTAC doesn't request a CF-18 fighter jet specifically. They simply input the target data, say a reinforced bunker, into the tablet.
They just say, I need this bunker gone.
Exactly. That digital request goes up into an automated headquarters network. And then an algorithmic system triages the request instantly.
Yeah, instantly.
It looks at the entire theater of operations. It sees a Canadian artillery battery 20 kilometers away, maybe a U.S. Navy destroyer offshore with cruise missiles, and a British drone loitering overhead.
Okay, so it sees everything available.
Right. The system calculates the trajectory, the payload required to actually penetrate that specific bunker, and the cost efficiency, and it automatically tasks the absolute best weapon for that specific target.
That is mind-blowing.
It compresses the decision-action cycle from minutes down to literally seconds.
And this directly ties into the RCA M.1 draft doctrine we reviewed.
It does.
Brigadier General Stéphane Masson, the senior serving gunner, wrote the foreword for that, and he used some very specific doctrinal language. He stated that the current forces are optimized for episodic readiness and contribution warfare.
Right, which is a very polite, highly sanitized way of saying the Canadian military is currently built to occasionally send a small battalion to help out an allied nation in a low-intensity peacekeeping or counterinsurgency role.
Like Afghanistan or Mali.
Exactly. It is a force tailored for isolated episodes of deployment. It is fundamentally not built for sustained, high-tempo major combat operations against a peer adversary like Russia or China in a contested environment.
Right, a near-peer war is a whole different beast.
Completely different. Massa emphasizes that the sensor-to-shooter chain must be integrated. The eyes on the battlefield and the weapons firing from miles away can no longer be separated by layers of bureaucracy and slow analog voice relays.
Okay, so we have the digital brain mapped out. We understand the ATAC tablet, the encrypted Link 16 hubs, and this grand vision of an automated JFM toolbox. But a brilliantly fast digital brain is completely useless without the physical muscle to actually strike the target.
No, 100%.
The Canadian military needed to prove that their artillery could actually operate in the harshest, most unforgiving environment on Earth, the Arctic.
And this physical reality check took place during Operation Nano-Nunalivin 2026.
Which is a massive exercise.
Huge.
Yeah.
The NANIC series of exercises has been running since 2007, but the 2026 iteration was the ultimate test. It stretched from February to April, covering vast expanses of the Northwest Territories, Nunavut, and the Yukon. We are talking about the largest Canadian Armed Forces contribution to this series ever.
And the logistics involved are just staggering. I mean, they deployed 1,300 CF members integrated with allied troops from the U.S., Belgium, France, and Denmark.
It's a lot of people to keep warm and fed in the Arctic.
Let alone moving them around. They moved nearly 200 vehicles across ice roads and frozen tundra. And the defense analysts in our sources heavily compared this modern operation to Exercise Muskox from 1946.
Oh, Exercise Muskox. That is a legendary piece of Canadian military history.
Yeah.
Yeah, right after World War II, the Canadian Army sent a small experimental force of tracked snowmobiles. Well, they called them snowmobiles back then, though they were really closer to light tanks.
Okay, so heavy tracked vehicle.
Right. They sent them on a 5,000-kilometer trek across the Arctic.
In 1946.
Exactly. They had no satellite communications, no GPS. They navigated using dead reckoning, magnetic compasses, and astronomical observations.
Navigating by the stars in -50, unbelievable.
The entire purpose was to see if a mechanized military force could even survive the terrain. And the primary lesson from 1946 remains true today. The North is actively hostile, and it destroys the unprepared.
So fast forward 80 years. The military already knows they can survive a patrol, but the objective for NANIC 2026 was unprecedented. They wanted to prove they could deploy heavy, lethal firepower up there.
Right, taking the big guns north.
Exactly. So they took M777 155mm howitzers. And just to visualize this, these are massive, traditional towed artillery pieces that weigh over 9,000 pounds.
They are absolute beasts.
And they loaded them onto C-130 Hercules cargo planes. They flew them north of the 60th parallel, landing in Cambridge Bay, Nunavut for the very first time.
Achieving that airlift alone is a monumental logistical victory. The M777 requires a large crew to operate. It requires heavy prime mover trucks to tow it from the airstrip to the firing position.
You can't just drop it and shoot it.
No. Getting the guns, the ammunition, the trucks, and the personnel thousands of kilometers north, entirely within Canada's own borders, proved a massive expeditionary capability.
So they get up there, they establish the firing points, they set the artillery pieces up in wind chills, plunging to -60 degrees.
Freezing their hands off.
Literally. The crews manually loaded the 100-pound high-explosive shells, they set the digital fuses.
And then
Nothing.
They
didn't shoot. The sources detail a cascading series of failures, and the crazy part is, it wasn't the artillery itself that broke first. A hangar door froze shut.
A hangar door?
Yeah. Extreme temperatures, crippled support equipment, and then sudden airspace coordination issues with Transport Canada ground the entire live fire exercise to a halt. The shot was canceled.
Wow. The frozen hangar door is just the perfect embodiment of Arctic friction.
It really is.
Because think about it. The door freezes, which means the CH-147F Chinook transport helicopters trapped inside cannot launch.
Right?
And because the helicopters cannot launch, a secondary patrol cannot be extracted or resupplied.
A domino effect.
Exactly. Operations that take hours in southern Canada take days in the high Arctic, because the sheer physics of the cold alters the properties of metal, it alters hydraulic fluid, and obviously human endurance.
This is where I struggle with the narrative of high-tech dominance, right?
How so?
Well, we are discussing the acquisition of multi-billion-dollar precision strike networks, and yet a frozen piece of metal on a building prevented a 9,000-pound howitzer from doing its job. Are we completely blind to the reality of the Arctic environment?
It's a great point.
It just seems like we are putting immense faith in delicate technology while ignoring the brute force of nature.
It's a critical observation, and honestly, it is exactly the hard truth the military took away from this exercise. Lieutenant Colonel Jordan Beatty, the Land Task Force commander, was actually refreshingly candid in the post-action reports.
Oh, what did he say?
He noted that while the soldiers themselves performed brilliantly, suffering zero serious cold weather casualties is a massive testament to their training.
Absolutely.
But the equipment and the infrastructure were pushed completely beyond their limits. Beatty referred to this as the unknown stuff.
The unknown stuff.
Yeah. You cannot drop complex mechanical and digital systems into deep snow and -60 temperatures and expect them to function as they do in a temperate training ground in, like, New Brunswick.
Yeah. Which perfectly explains why the sources emphasize the actions of a completely different group during this operation. The 1st Canadian Ranger Patrol Group.
Yes, the Rangers.
While the heavy artillery was getting grounded by frozen doors and bureaucratic airspace issues, the Rangers were executing a 5,000-kilometer snowmobile patrol stretching from the Yukon-Alaska border all the way to Hudson Bay.
The contrast there is striking and deeply intentional.
How do you mean?
Well, the Rangers are a specialized component of the Canadian Armed Forces Reserve, and they're drawn heavily from Indigenous and local northern communities.
People who actually live in this environment.
Exactly. They do not rely on fragile logistics chains or heated hangars. When high-tech GPS screens froze blank and headquarters digital maps failed to reflect the constantly shifting sea ice, the Rangers navigated using traditional knowledge.
Right, they didn't need the screens.
They read the sastrugi, which are the hard ridges carved into the snow by the prevailing winds, to maintain their headings. They understood the ice thickness implicitly just by looking at it.
That's incredible. They successfully completed a massive continent-spanning patrol using snowmobiles and intrinsic environmental knowledge, while the high-tech, heavy muscle of the regular army was literally frozen in place.
And that stark reality is exactly what shifted the strategic calculus at the highest levels of the military. The Army commander, Lieutenant General Michael Wright, observed this and stated that the Arctic is becoming a region of intense geopolitical vulnerability.
Because the ice is melting, right?
Right. We're seeing Russian submarine and air activity increasing. The ice is receding, opening up new maritime transit routes. The military needs to defend this massive coastline. But Wright noted that getting there is no longer the primary hurdle. Holding it is.
Okay, so if the Arctic guarantees that permanent infrastructure will eventually freeze, fail, or just be easily targeted by an adversary, then traditional towed artillery like the M777 is a massive liability.
Massive.
Because you need an entire team of soldiers standing outside in a blizzard to load it, and it can't move quickly once it fires.
That vulnerability forces a transition to the concept of area denial.
Area denial.
Area denial means possessing the capability to destroy any hostile ship, aircraft, or ground force that attempts to enter your territory.
To basically say, if you come here, you won't survive.
Exactly. To achieve area denial in the Arctic without relying on permanent, heated, heavily defended bases, you must have a weapon system that brings its own mobility. It must be entirely self-contained.
Okay.
It must strike from hundreds of kilometers away, and it must be able to drive away before the environment or the enemy can destroy it.
Which brings us directly to the star of the show, the $2.6 billion solution to the Arctic problem, the HIMARS.
The High Mobility Artillery Rocket System, designated as the M142.
Right.
Canada is finalizing a foreign military sales agreement with the United States to purchase 26 of these launchers.
Now, the Department of National Defense was adamant in their press releases that HIMARS was the quote-unquote only solution that met their operational and technical requirements.
They definitely pushed that narrative.
But if you step back and look at the global defense market, there are massive defense contractors building incredible rocket systems.
Was HIMARS genuinely the only option on the table?
It is a fiercely debated point, especially in the Our Canadian Forces Reddit thread we analyzed.
The Reddit thread was spicy.
Very. The defense community is well aware of the competitors. For example, you have the Hanwha Chunmoo, manufactured by South Korea.
The Chunmoo?
Yeah, it is an absolute beast of a system, boasting a 290-kilometer range, and Poland is currently buying hundreds of them.
Oh, wow.
You also have the Elbit PLS system from Israel, which is highly modular and was just selected by the Netherlands and Germany to rebuild their artillery forces.
So there are clearly other very viable options.
Exactly. Both of these alternative systems can fire a wider variety of rockets than the HIMARS, and in the case of the Chunmoo, it carries double the payload.
Double. So why spend $2.6 billion on the HIMARS if it carries half the missiles of the South Korean competitor?
Right.
We were reading through that Reddit thread, and a user named SubstantialFruit447 actually cut through all the political noise and nailed the core logistical constraint.
Oh yeah, they hit the nail on the head.
They pointed out that the Chunmoo is simply too heavy.
Logistics dictate tactics. The HIMARS was specifically engineered from the ground up to fit perfectly into the cargo bay of a C-130J Hercules transport aircraft.
Which is the plane Canada already has a lot of.
Exactly. The Chunmoo is a fantastic system, but it is mounted on a much heavier 8x8 truck chassis. If you want to move the Chunmoo quickly by air, you need a massive strategic airlifter like an A400M Atlas or a Boeing C-17 Globemaster.
And Canada relies heavily on its fleet of tactical C-130 Hercules aircraft.
Right.
If you buy a massive, heavily armed rocket launcher, but you can't actually fit it inside the planes you own to fly it up to Yellowknife or Cambridge Bay, then you don't really have an Arctic strike capability at all, do you?
Not really.
You just have a very intimidating truck parked in southern Ontario. That is the defining compromise of military procurement. A weapon system's value is directly tied to its deployability. Yes, the HIMARS carries only one 6-pack missile pod compared to the 2 pods carried by the heavier tracked M270 or the Chunmoo.
Right.
But the HIMARS isn't just a truck, it is an expeditionary ecosystem. Because it is wheeled and relatively light, weighing around 36,000 pounds fully loaded, it can perform what artillery crews call a shoot and scoot.
Okay, let's visualize a shoot and scoot scenario. Walk me through what a HIMARS crew is actually doing during a deployment in the north.
All right, imagine a HIMARS crew receives a digital target package via that Link 16 network we discussed earlier.
On their ATAC tablet.
Exactly. They are parked miles away from the target, perhaps hidden in a tree line in the Yukon. The 3-person crew, which is just a driver, a gunner, and a launcher chief, they never have to leave the armored heated cab.
Which is a huge deal at -60.
Massive. The vehicle drives to a designated firing point. The onboard computer automatically calculates the precise elevation and azimuth required, taking into account meteorological data like wind speed and air density.
So the math is done for them.
Instantly, the launcher pod elevates, the rockets fire, creating a massive overpressure wave and a blinding plume of smoke.
And the moment those rockets clear the launch tubes, the clock starts ticking.
Immediately. Modern adversaries possess what's called counter-battery radar.
What does that do?
These are radar systems that detect the incoming artillery shells in midair, calculate their parabolic flight path backward in a fraction of a second, and pinpoint the exact location where the rockets were launched.
Oh, wow. So they instantly know where you are.
Within minutes, the enemy will fire their own artillery at that launch point.
So the HIMARS crew has to disappear.
Exactly. They lower the empty pod, put the truck in gear, and drive away at highway speeds. By the time the enemy artillery strikes the firing point, the HIMARS is miles down the road, completely safe, and preparing to load a fresh pod of missiles.
That is incredibly efficient.
And in the vast open expanses of the Arctic, that mobility is the only thing that guarantees survivability.
Now, beyond the mobility, there is the interoperability factor, right? Buying HIMARS plugs Canada directly into the NATO supply chain.
Right. Interoperability is a massive force multiplier here. The United States, the UK, Poland, Romania, Australia, they all operate or are acquiring HIMARS.
So they all use the exact same ammo.
Exactly. In a coalition environment, a Canadian HIMARS launcher could roll up to an American ammunition dump, load an American missile pod, receive targeting data from a British drone via the digital tablet, and execute the strike seamlessly.
The sources also highlight a future capability that honestly blew my mind. These HIMARS launchers are slated to eventually integrate land-based anti-ship missiles.
Yeah, that's a game changer.
We are talking about taking a truck, driving it to the edge of the Arctic sea ice or just a coastal highway, and turning it into a naval area denial weapon.
Yes.
You can sink a warship from a vehicle that looks like a standard logistics truck.
It fundamentally alters the geometry of coastal defense. But a launcher, no matter how mobile or digitally connected, is still just an expensive delivery vehicle.
Right.
To grasp the true strategic impact of this $2.6 billion procurement, we have to look inside the missile pods themselves. We have to examine the payload.
So according to the Defense Security Cooperation Agency release, Canada's request is highly specific.
Very specific.
They are asking for 132 pods of the M31A2 unitary rockets, 132 pods of the M30A2 alternative warhead rockets, 64 pods of extended range variants, and crucially, 64 pods of the M57 ATACMS.
Okay, let's break down that alphabet soup, starting with the M30 and M31 series.
Yeah.
These are the GMLRS, which stands for Guided Multiple Launch Rocket Systems.
Okay, GMLRS.
The standard GMLRS rockets have a range of roughly 70 to 80 kilometers. The M31A2 unitary carries a 200-pound high-explosive warhead designed for point targets.
Like a specific building.
Exactly, like a specific building or reinforced bunker. It detonates and destroys the structure through pure explosive blast and overpressure.
But the M30A2 alternative warhead is fascinating because of how it solves both an ethical and a logistical problem.
It really is a marvel of engineering.
Older artillery systems used cluster munitions, right? Scattering hundreds of unexploded bomblets across a field, which left a deadly mess for civilians long after the war ended. The alternative warhead does not use cluster bombs.
Right. Instead of explosive submunitions, the M30A2 warhead is packed with roughly 182,000 preformed tungsten fragments.
Tungsten fragments.
Yeah. When it detonates directly over a target, it acts like a massive, precision-guided shotgun blast.
Wow.
It covers a vast area with high-velocity tungsten spheres, devastating unarmored vehicles, radar sites, and personnel in the open, but it leaves zero unexploded ordnance behind.
So it's highly lethal, but completely compliant with international treaties banning cluster munitions.
Exactly. It's a very clean, very brutal capability.
That covers the short-range tactical strikes. But the crown jewel of this acquisition is the 64 pods of the M57 ATACMS, the Army Tactical Missile System. This is the big stick.
It is a completely different class of weapon. To understand the ATACMS, we need a brief historical deep dive. Its conceptual origins trace back to the 1980s Cold War era under a DARPA program ominously named Assault Breaker.
Assault Breaker.
Yeah.
Sounds intense.
Well, the doctrinal nightmare of the 1980s was a massive Warsaw-Pact tank invasion pouring through the Fulda Gap into Western Europe.
Right, the classic Cold War scenario.
The U.S. realized they needed a conventional, meaning non-nuclear tactical ballistic missile that could fly deep behind enemy lines and obliterate the second echelon Soviet reserve forces before they could even reach the front line.
So they built the ATACMS, and it made its combat debut in 1991 during Operation Desert Storm, right?
Right.
Where they fired 32 of them against Iraqi forces.
Yep.
Then during the 2003 Iraq War, that number jumped to over 400. But we don't have to look at history books to see its capability today. The illustrative content from recent conflicts shows exactly what this missile does to a modern adversary.
Look at the Russo-Ukrainian War from 2023 to 2024. When Ukraine finally received ATACMS from the United States, the strategic impact was immediate.
How so?
They fired them at Russian air bases in occupied Crimea. Satellite imagery showed the aftermath. Advanced K-52 attack helicopters were completely destroyed while just sitting on the tarmac.
Wow.
They used them to systematically dismantle advanced S-400 air defense radar systems. And in February 2026, they struck a heavily defended Russian Fifth Army Auxiliary Command Post.
Our sources also reference the hypothetical 2026 Iran war games and reports, where top U.S. generals detailed using ATACMS to sink Iranian warships, including a submarine at port,
Right.
a ground-based truck launching a missile that sinks a submarine. How does the physics of this strike actually work? Why are sophisticated air defense systems failing to shoot these down?
It comes down to terminal velocity and an almost vertical trajectory.
Okay, walk me through that.
When the HIMARS crew pushes the launch button, the solid rocket motor of the ATACMS ignites. It accelerates to supersonic speeds exceeding Mach 3.
Mach 3.
It punches through the lower atmosphere and arcs up to 160,000 feet, which is the very edge of the stratosphere. It then pitches over and plunges almost straight down onto the target.
So it's a 500-pound blast fragmentation warhead falling out of the sky at Mach 3?
Yeah, air defense interceptors simply cannot calculate the intercept geometry fast enough to catch something moving vertically at that speed.
And it isn't just a dumb rock falling from space. It is actively steering itself.
Exactly. It's guiding itself all the way down.
Which brings up a critical vulnerability we see constantly in modern warfare, electronic warfare.
I know for sure. Jamming is everywhere.
We see reports every day about GPS signals being jammed or spoofed. If your Mach 3 missile relies on a satellite signal to find the target and the enemy jams the GPS, doesn't your multi-million-dollar weapon just become a very fast, very blind lawn dart?
That is the exact fate of many cheaper precision munitions in highly contested electronic warfare environments.
Wow.
But the ATACMS is engineered specifically to defeat GPS jamming.
How?
It utilizes a GPS-aided inertial navigation system, or INS.
How does an INS actually work without satellites?
An inertial navigation system relies on internal physics, not external signals.
Internal physics.
Yeah. Deep inside the missile are incredibly sensitive ring laser gyroscopes and accelerometers. The moment the missile launches, the accelerometers measure every micro change in linear acceleration.
Okay.
And the gyroscopes measure every change in angular velocity, meaning the pitch, roll, and yaw of the missile. An onboard computer takes the exact known starting coordinate, and hundreds of times a second, it mathematically integrates those physical movements to calculate exactly where the missile is in three-dimensional space.
So it is constantly updating its own position based solely on how it feels itself moving.
Exactly.
Dead reckoning at Mach 3.
Yep. So even if the GPS signal is completely blacked out by enemy jammers, the internal gyroscopes keep guiding it to the target with terrifying accuracy.
The GPS is only there to correct minor drift over long distances then.
Precisely. The INS makes it functionally immune to electronic blinding. However, the exact variant Canada is buying, the older ATACMS, brings up a highly debated point in our sources.
Right. Let's look at the documentation regarding the replacement system. Lockheed Martin has already developed, and the U.S. military is already fielding the PRSM, the Precision Strike Missile.
Right, the newer model.
The PRSM debuted in combat during Operation Epic Fury in Iran in 2025. Now, the ATACMS has a maximum range of 300 kilometers. The PRSM boasts a range in excess of 500 kilometers.
It's a huge leap in range.
And because it is physically slimmer, a single HIMARS pod can hold 2 PRSM missiles, doubling the launcher's firepower compared to the single ATACMS.
So the natural question is, if the PRSM flies further, doubles the firepower, and has already proven itself in combat, why is the Canadian government writing a check for 64 pods of the older ATACMS?
Right. Are they investing billions of dollars into a legacy system that is already obsolete? Why buy an iPhone 14 when the iPhone 15 is already out and proven?
It is a very fair critique, but the answer comes down to industrial production capacity and integration risk.
What do you mean by integration risk?
Well, the ATCMS is a mature, battle-hardened weapon system. Every bug has been ironed out over 30 years. By purchasing the M57 ATCMS today, the Canadian Armed Forces take on absolutely zero integration risk.
It's guaranteed to work.
Exactly. They receive the pods, load them into the launchers, and they have an immediate guaranteed 300-kilometer strike capability on day one.
Whereas the PRSM production lines are likely maxed out.
Precisely. The U.S. military is consuming PRSMs to replenish their own stockpiles, leaving very little capacity for foreign military sales in the immediate short term.
That makes sense.
But the genius of the HIMARS ecosystem is its forward compatibility. The software and the physical launch rails are designed to accept new munitions.
So the truck stays the same?
Right. The Canadian defense strategy assumes that as the PRSM supply chain stabilizes over the next few years, Canada will naturally transition to purchasing those new pods. You buy the delivery truck today with reliable cargo, and you upgrade the cargo tomorrow, seamlessly giving the Canadian Army that 500-kilometer reach without needing to buy a whole new launcher.
The phrase supply chain is the perfect pivot to the final and perhaps most fiercely debated element of this entire $2.6 billion acquisition.
Oh, this is the big one.
Buying the missiles is the easy part. Keeping the launchers supplied with ammunition during a prolonged conflict is an entirely different beast. We have to look at the vulnerability of sovereign supply chains.
If the conflict in Ukraine taught the modern military establishment anything, it is that the expenditure rate of precision munitions in a peer-to-peer war is astronomical.
Yeah, they use them up so fast.
Militaries are burning through stockpiles in weeks that they assumed would last for years of sustained combat.
And when you run out of missiles, your $2.6 billion fleet of HIMARS launchers just becomes a fleet of very heavy, very expensive empty trucks hiding in the snow.
Which is useless.
Yeah.
This vulnerability is why defense analysts are pointing directly to the blueprint established by Australia.
Okay, let's talk about Australia.
The article from the Canadian Defense Review, Australia's HIMARS success offers blueprint for Canada, details a fundamentally different approach to procurement. Australia isn't just handing over a check to the U.S. for fully assembled HIMARS systems.
What do they do?
They are aggressively domesticating the supply chain through their Guided Weapons and Explosive Ordnance Initiative, the GWEO.
Okay, so Australia recognized the geopolitical danger of relying entirely on overseas shipping lanes for their ammunition.
Exactly.
So they stood up local manufacturing. They recently successfully test-fired GMLRS rockets that were assembled domestically in Australia from their own HIMARS launchers.
Right. They are transitioning from being a vulnerable consumer to an independent producer.
Now, contrast the Australian GWEO initiative with Canada's current posture. The Department of National Defense press release openly acknowledged that there is currently no Canadian manufacturer capable of producing the HIMARS launchers or the complex rocket munitions.
None. Canada is entirely reliant on the American production line.
To offset this, Canada uses the Industrial and Technological Benefits Policy, the ITB.
Right.
The ITB mandates that when the government buys foreign defense equipment, the winning contractor, Lockheed Martin in this case, must reinvest an equal value back into the Canadian economy. They are required to integrate Canadian firms into their global supply chain.
But this policy sparked massive anxiety in the public discourse we reviewed. In the Reddit thread, users were intensely cynical about this arrangement.
Oh, they were not holding back.
Not at all. One user pointed out the historical reality of global conflict, saying, I have the feeling they're going to deplete their own stockpiles and then fail to give us the ones they agreed to because they need them more.
And just to be completely clear to our listener, we are not taking a political stance on this.
Right. Definitely not.
Whether you approach this from a left-wing perspective concerned with foreign policy dependence or a right-wing perspective focused on national sovereignty, we are impartially reporting that this anxiety over supply chain security is a universal concern.
Because when the global security environment degrades, does the producing nation prioritize its own stockpiles over its allies?
History suggests that during an existential crisis, nations prioritize their own survival.
They absolutely do. If Canada cannot domestically produce solid rocket motors, the complex chemical energetics for the warheads, or the microelectronics for the guidance systems, their $2.6 billion capability is essentially held hostage by another nation's goodwill and industrial capacity.
Wait, if Australia has the industrial willpower to assemble these rockets domestically, why is Canada seemingly content with just integrating into global supply chains through this ITD policy? Shouldn't we be demanding local assembly plants right here in Canada? It feels like we are settling for a half measure.
It is a compelling argument for total sovereignty. But total sovereignty in complex aerospace manufacturing is incredibly expensive and often inefficient.
Okay, so what's the alternative?
Well, integrating into the supply chain might actually be a much smarter, more resilient strategic play for Canada. You do not necessarily need to build the entire missile from nose cone to exhaust nozzle to guarantee access.
You find the choke point and own it.
Exactly. Canada possesses immense world-class expertise in specific aerospace sectors: advanced composite materials, precision optics, and complex electronics.
Right.
The chemistry involved in mixing the highly volatile solid rocket propellant without creating voids or cracks is notoriously difficult. If, under the ITB policy, Canada becomes the sole or primary North American manufacturer for specific high-demand bottlenecks, say the seeker technologies in the nose cone or the specific chemical energetics for the solid rocket motor, they completely change the power dynamic.
I see where this is going. Instead of building the whole car, we become the only factory on the continent that knows how to build the engine block.
Yes. And once you achieve that, the American assembly lines become just as desperately reliant on Canadian components as Canada is on the finished American missile.
Wow, that's clever.
It creates a state of intertwined resilience. The U.S. cannot finish their own missiles without the Canadian parts, which structurally guarantees that the supply chain remains open to Canada even in the midst of a global crisis.
It is a modern, highly integrated definition of sovereign defense capability.
It isn't about isolationism. It is about making yourself absolutely indispensable to the allied ecosystem.
Let's synthesize this massive journey we have taken today. We started by looking at the analog vulnerability of the JTAC, spending 20 agonizing minutes reading 9-liners over static-filled radios while carrying 50 pounds of batteries.
It's a completely outdated way to fight.
Yeah. We traced the digital revolution that replaced that burden with an off-the-shelf Google tablet, linking soldiers into an encrypted, automated Joint Fires toolbox, capable of orchestrating a multinational strike in under 2 minutes.
We then confronted the physical reality of Operation Nanook in the high Arctic, where a frozen hangar door and -60-degree wind chills proved that traditional heavy-towed artillery requires a level of permanent infrastructure that simply cannot survive the North.
We contrasted that high-tech failure with the low-tech traditional survival skills of the Canadian Rangers.
Which illuminated exactly why Canada wrote a $2.6 billion check for the HIMARS.
Right. They needed a system that brought its own mobility, capable of rolling off a C-130 Hercules, executing a shoot-and-scoop mission, and surviving the elements without a heated base.
We unpacked the devastating payload of those launchers, from the tungsten-showering alternative warheads to the Mach 3 GPS jamming-resistant ATACMS ballistic missiles.
And we explored the strategic necessity of intertwining Canadian manufacturing into the global supply chain, to guarantee those launchers never run out of ammunition.
This deep dive reveals that this isn't just a gear upgrade for the Canadian Armed Forces.
Not at all.
It is a violent, fundamental shift in military doctrine. As Brigadier General Masson's in-point draft indicated, Canada is actively abandoning the mindset of episodic readiness and soft power peacekeeping.
They're pivoting aggressively toward a posture of hard power, long-range area denial.
They are building a force capable of reaching out and neutralizing a threat before it ever crosses the horizon.
Which brings me to a final, deeply provocative thought that has been lingering in my mind as we synthesized all these sources. We discussed how these truck-mounted HIMARS launchers are going to integrate anti-ship missiles.
Right.
And we saw the reports from 2026 where the ATACMS was used to sink a submarine sitting in port.
It completely dismantles the traditional boundaries of military domains.
For over a century, the lines of engagement were neatly categorized. The Navy fought other ships on the ocean.
The Air Force bombed strategic targets deep behind enemy lines.
And the Army fought other soldiers on the dirt. But if a handful of ground troops driving a wheeled logistics truck can now sink multi-billion-dollar warships off the coast, obliterate air defense systems hundreds of kilometers inland, and orchestrate the entire symphony of destruction from a commercial tablet, those lines are entirely erased.
The ground soldier is no longer just holding territory. They are actively dictating the naval and aerospace domain.
So here is the question to mull over on your own after this deep dive. What happens to the future of global warfare when the ground soldier becomes the ultimate anti-ship and strategic strike commander?
Scary thought.
What does it mean for global power dynamics when an adversary's multi-billion-dollar naval frigate or their fleet of next-generation fighter jets is suddenly fatally vulnerable to a single truck hiding quietly in the Arctic snow?
It forces every adversary to entirely rethink how they approach the North.
You tap the glass screen. 2 minutes later, the target ceases to exist. It truly is a whole new world. Thank you for taking this deep dive with us today. We hope this exploration gave you a solid mechanical grasp of how fast the landscape of defense and technology is shifting beneath our feet. Stay curious, keep questioning the underlying systems that drive the world around you, and if you want to fall down the rabbit hole yourself and look at the specs of these systems, check out the sources we used for this discussion. See you next time.